Hi everyone, and welcome to section 5.5. Today we're going to talk about using inequalities in triangles, and also a little bit of section 5.6, which is the Hinge Theorem. On theorem 510, essentially, with the inequalities, if one side of a triangle is longer than the other side, then the angles opposite the longer side is larger than the angle opposite the shorter side. To put it in a little bit more sense, if you take a look at example number 1, listing the angles in order from smallest to largest, you're going to have to agree with me with this, whereas if 20 is the biggest side, then angle G is our biggest angle. Kind of like on the flip side here, if the side that has 12, which is RG, is our smallest side, then angle H is going to be our smallest angle. So we're going to list these from smallest to largest based on the adjacent side. So for example, angle H would be our smallest because 12 is our smallest measure. Angle R would be in the middle because 14 is what it corresponds to. And then, of course, like I said, angle G being our largest because the opposite is the largest side. Remember, anytime through these videos, if you want to back up, you're more than welcome to. You can always hit pause, rewind, or even pause and try the problems yourself. The next theorem that we have is if one angle of the triangle is larger than the other, and the side opposite the larger angle is longer than the side opposite the smaller angle. Essentially what we're doing now is instead of having the sides that we're looking at, we're going to look at the angles. Same exact rule applies, just the opposite way. The biggest angle means that the opposite side is our largest. List the sides in order from smallest to largest. If you want to try this first, you can. If you're done pausing the video, you might want to note that if we have 180 minus 120 minus 35, we end up with 25. So finding this angle is definitely good because it is now our smallest side. So 25 corresponds with MN as our smallest side. 35 then corresponds with ML. And then our 120 degree, and it's kind of obvious to see based on this picture, is going to be LN. Now, pay close attention. Sometimes the pictures aren't necessarily drawn to scale, or you might have two sides that look very, very similar. Using the angle measures will help you to determine which side is greater and which side is least. Next up, we've got triangle inequality theorem. Essentially what this is if we're given two sides of a triangle, we need to make sure that the smaller two sides, when added together, are greater than the bigger side. Otherwise, the triangle cannot have those three specific sides. For example, if you take a look at number 3, can a triangle have sides with the given lengths? Essentially what we're trying to figure out is if I added these together, would they be greater than my largest side? In this case, 2 plus 7 is not necessarily greater than. So in this case, we would say no. And because we want to look at all the sides, we would also set up other inequalities such as 2 plus 9 is greater than 7, and 9 plus 7 is greater than 2 to get the full aspect. Now, to be honest with you, since this one is no, we don't need to test the other sides. Only whenever they're yes do we test all the other sides. Let me show you another example here. Say, for instance, we have 3, 6, and 8. Well, 3 plus 6 is greater than 8. 9 is greater than 8. 3 plus 8 then has to be greater than 6, which is true. And then 6 plus 8 has to be greater than 3, which is also true, which means because all 3 of these are now true, that this can be a triangle. Okay, we can have a triangle with these sides. So what happens if they don't give us the side? Example 4, the length of 2 sides of a triangle are given. Describe the lengths possible for the third side. Let's make that next side x inches. Now let's take a look and see what possible explanations we could have for this. Got 3 plus x is greater than 12. 12 plus 3 is greater than x. And 12 plus x is greater than 3. So here we have x has to be greater than 9. X has to be, or 15 has to be greater than x, which means x has to be less than 15. In this case, x has to be greater than negative 9. Obviously, we don't have to necessarily use this one. We know that x has to be greater than a negative number. However, whenever we're looking at these two, these are the main ones that we want to look at. Anytime you get a negative number, it's mainly just obsolete because we're dealing with length and distance is never negative. So in this case, x has to be greater than 9. So we could write it as 9 is less than x, which is less than 15. This is what we call a compound inequality. Or we could just write it x is greater than 9, or x has to be less than 15, which means x could be the numbers 10, 11, 12, 13, or 14. So that kind of rounds up what 5.5 is. 5.6, we talk about the Hinge Theorem. Hinge Theorem essentially says that if 2 sides of one triangle are congruent to 2 sides of another triangle, the included angle in the first is larger than the included angle of the second, then the third side of the first is longer than the third side of the second. Kind of makes sense whenever we're looking at it and we're referring to our triangle, our triangles that we talked about in Theorem 5.5, which stated that if one side of a triangle is longer than the other, then the angle opposite that longer side is larger, or the side is larger. The converse to this is if 2 sides of one triangle are congruent to 2 sides of another, and the third side of the first is longer than the third side of the second, then the included angle of the first is larger than the included angle of the second. Let me kind of show you here with example number 5, and hopefully this kind of makes sense. I'll show you an example of converse. Given that BC is congruent to DC, how does ACB compare to ACD? Well, first off, we need 2 sides that are going to be congruent. We've already got one, BC and DC, but then we also need our other. Luckily, both these triangles share AC together. Now we look at the sides. Okay, we've got 16 as a side here. We've got 15 as a side here, which means that this is going to be a larger angle here than this angle would be here. Okay, so how does angle ACB compare to angle ACD? The measure of angle ACB is greater than the measure of angle ACD. And because we use the sides in order to prove this, this is going to be our converse Hinge theorem. Hopefully this makes it so it's not too difficult for you, and you can go ahead and try example 6 and 7 on your own. Okay, hopefully you paused the video, taking a look at this here. We've got KL, and we need to know if it's greater than, less than, or equal to NP. If we look at those angle measures, this is going to be our Hinge theorem because we're starting with the angles. if we're looking at our angle measures, you can see that the one is 80 and the other one is 75. Because of this measure being greater, angle M is greater than angle J. We can say then, based off of this, what our observations are going to be. So KL actually is going to be less than NP because we're looking at KL first. This would really be like saying angle J is less than angle M. The measure of angle 1 blank the measure of angle 2. If you tried example number 7, you know that this is the converse of the Hinge theorem. We start with the sides. So they both have a side that is congruent here and here, and then they both share this middle one, which is congruent. What we're looking at is 12. 12 is actually less than 22. So in this case, the measure of angle 1 is going to be less than the measure of angle 2. That's all I've got for your notes today. Please make sure, again, if you need any more explanation, to get in touch with me. Also, you can rewatch this video or try and find any other videos out there on the internet based on Hinged Theorem. Make sure that you do the homework assignment associated with the video. Thanks. Have a great day.